So we were also dealing with temperature conversions in our pseudocode. So how about if we write the program for that temperature conversion? Because it's a full-blown program, we're going to actually map out a plan. We'll fill in the details and rewrite the source code. I'm going to call this temperature conversion 1 because we're going to write a second one. So maybe the first step is to declare some variables. That would be a good place to start. I'm pretty sure that we're going to, how about if we convert Fahrenheit to Celsius? Then we want to display the results. So this is my basic plan. I'm going to circle back around step number 2 and fill in some detail. And so displaying the results, that's a good place to start. What would I like it to say? Maybe what I would like to say is 25 degrees Fahrenheit is, I don't know, 19 degrees Celsius. Now, when I'm creating my print statements, I'm not worried about the actual numbers or math working. I'm just looking for the format of the statement that I am trying to print. The next one is to convert Fahrenheit to Celsius. Well, I don't know how to convert Fahrenheit to Celsius, and so I'm going to do a handy-dandy Google search, and I'm going to come up with a formula that says Celsius is equal to Fahrenheit plus 32 multiplied by 5 divided by 9. All right, so I get this. Oop, I need that opening parenthesis here. So I got this formula. Now I know what it is. And the next part of step 2 is, what variables do you think that I'm probably going to need for this? Again, 3 places that I can look. Things that I prompt the user for, calculations that I am doing, and things that I am displaying to the user. Well, just based upon my display, I'm going to try to display Fahrenheit and Celsius. I'm going to be calculations using Fahrenheit and Celsius, which means that I probably need Fahrenheit and Celsius as variables. All right, step number 3. Let me save this just to make sure I don't accidentally delete it. Step number 3, we're going to come in and we're going to fill in our pseudocode with actual source code. So I'm going to create a Fahrenheit variable. I'm going to set it to, how about we set Fahrenheit equal to, we'll set it equal to 100. And then Celsius. We'll create a Celsius variable. We're going to set it equal to a floating point value. The second step is to use my handy-dandy formula in order to do the conversion. This says that Celsius is equal to the Fahrenheit variable added to plus, we're going to do plus 32. I can make that a float value if I want. Then we're going to multiply that by 5 divided by 9. And then we're going to display the results. So one of the things that I could do to display this result is that we could use a print statement, and we can build this print statement, because I'm pretty sure that this is a variable, and this right here is a text field. This is a variable, and this is a text field. So it looks like I have variable text, variable text. I have spaces between all of it. So it seems like I could do a comma separator. There's a text field, comma separated from another variable, comma separated from my final text field. Because I took all the time to type it in, I'm just going to copy degrees Fahrenheit is. I'll copy that and put it in that text field. And then degrees Celsius, I'll copy that and put it in the last text field. All right. So I don't actually know what 100 degrees Fahrenheit is in Celsius. When I run it, it gives me a value, but I don't know if that value is correct. But I do know that 212 degrees is the boiling point of water. And I know that that is equivalent to 100 degrees Celsius. So when I run the program, I would expect it to say 212 degrees Fahrenheit is 100 degrees Celsius. I'm going to run the program, and it's going to give me a different value, 135. So that means one of two things. Either my program is wrong or my test case is wrong. Because I say that 212 degrees Fahrenheit should be 100 degrees Celsius. So Either I am wrong or my program is wrong. This is the reason why we create test cases and not just run it and just accept whatever it's saying. So I'm going to do a Google search and I'm going to find out that 212 degrees Fahrenheit is indeed equivalent to 100 degrees Celsius, which means that there's something in my program that's wrong. I'm going to go back and I'm going to do a Google search on my conversion formula, and I'm going to find out that this is actually Fahrenheit minus 32, not Fahrenheit plus 32. So I'm going to change it to the minus 32. I'm going to run it again with 212. This time when I run it, it is giving me the 100 degrees Celsius. This is the reason why we run test cases, to find out if we have logic errors. So this is an example of a logic error. If I was not paying attention to it, I would not know that my program is generating the wrong answer. So now that I believe it's working correctly, I know that 32 degrees Fahrenheit is the freezing point of water. So 32 degrees Fahrenheit should equal 0 degrees Celsius. It's giving me the correct answer. There's only one other value that I know off the top of my head, and that's a negative 40. Just based upon the math, a negative 40 Fahrenheit is equivalent to a negative 40 in Celsius. So now that I have run several test cases to make sure that my program is indeed running correctly, now I can put in other strange and bizarre numbers like, I don't know, 250. And when I run it, I can be reasonably assured, because I've tested it, that it has indeed given me the correct answer, because I ran it against some known test cases. But one of the problems that I'm seeing is that there is entirely too many decimal places. So let's see if we can generate a more user-friendly display. I would like to be able to force decimal places. So in order to do that, we're still going to use our print, but instead of just typing in things inside of the print statement, in front of the double quotes, I'm going to put the letter F. Outside of and in front of the quotes, I'm going to put the letter F, and we're going to do what is called a string format. And this is really what I'm trying to say right here. 25 degrees Fahrenheit is 19 degrees Celsius. Since I took all the time to type it up, I'm just going to copy it, and I'm going to paste that whole entire string into my print F statement between the quotes. But you say to me, wait a minute, that 25 is actually supposed to be the variable. Well, I am going to use the curly braces, and I'm going to put the name of the variable that is supposed to be. And then I'm pretty sure that 19 is also supposed to be a variable. So I'm going to replace it with a curly braces, and inside of there, I'm going to tell it the name of the variable that should be there. So now let's run it again with my strange and bizarre number up here. If I run it again, it's running exactly the same. I can see that these two print statements are doing the exact same thing. But wait a minute, we were supposed to be doing decimal places, right? The whole point of this activity was to create decimal places. So I'm going to copy this and I'm going to paste it down here. And then we were doing this so that I could have decimal places. So I'm going to come inside of the curly braces to the Fahrenheit variable. Let's see if we can force it to one decimal place. So I'm going to do a full colon, followed by a .1, followed by the letter F. Now, the colon tells me that I'm going to be using some switches on this. The .1 says that it will be one decimal place, and the F tells me the data type of this variable. Far happens to be a floating point variable. I'm going to come down here to Celsius, and we're going to try Celsius. I'm going to do the full colon. Let's see if we can force this to 2 decimal places. I know that Celsius also happens to be a floating point. We'll just see if I can force Celsius to 2 decimal places. We'll run it again. And now indeed I have forced decimal places. So my Fahrenheit is 1 decimal place. My Celsius is 2 decimal places. So we were able to modify our print statement to be a lot more user-friendly. Instead of doing all the comma separated, plus separated, strings and variables on line 19, we can actually just paste in an entire string print statement and then replace the variables with the hard-coded values with the specific. So what would make my temperature conversion more robust? Right now I can sell it on the App Store to my absolute closest family who love me the most. They would probably be willing to pay 25 cents for this. But I'm going to have one on the App Store to convert 2,145 degrees Fahrenheit and 212 degrees Fahrenheit and negative 40 degrees Fahrenheit. What would make this more robust is if I could ask the user for the temperature that they would like to convert. So that's what we're going to do next.